Hey there. AI can generate an entire application in just minutes, but should you let it? I'm going to give you 5 rules for using AI to build software without accruing a lot of technical debt. Here's the reality. Without proper engineering discipline, that generated code becomes technical debt faster than you can deploy it. Today, I'm building a production-ready ASP.NET application from scratch using GitHub Copilot, but following the same SDLC practices you'd use on any enterprise project. You'll see exactly where AI accelerates your work and where you need to take control. Now, before we even get started with our project, we're going to create an agents markdown file. Think of agents.md as your project's constitution. When it's present, AI tools like Copilot, and a lot of the other ones utilize this as well, automatically read this file and use it as context for every interaction. This isn't just a convenience, it's to help provide discipline. Without clear guidelines, you'll get inconsistent suggestions that don't align with your architecture decisions and even with the rest of your project. So here's what I'm going to put in our agents.md file for this project. I'm going to specify we want a 3-tier architecture with clear separation of concerns. The presentation tier will be ASP.NET Web Application. We're going to create a separate project for the service layer to contain business logic. We're going to use Entity Framework for data persistence. We're going to use dependency injection throughout the application. If it's complicated enough, we'll provide a repository pattern for our data access and abstraction. We're going to utilize view models in the web tier, and we're going to enforce the interface segregation principle for loose coupling within the application. We're also going to specify our coding standards, our testing strategies, TDD in particular, as well as other architectural guardrails. Rule number 1, set architectural guardrails. Document your architecture decisions and coding standards so that AI can follow the playbook that we give it. So make sure this is a good one. You can reuse this file on other projects as well. And as we make our way through this project, we'll discover things that we need to go back and add to agents.md because we'll see Copilot going off in rabbit holes that we don't want it to go down. Next, we need to define what we're building. For that, we'll create a requirements.md file. And that brings me to rule 2. Start with clear requirements. This document captures the product vision, user stories, functional requirements, and non-functional requirements. I'm going to start with just a simple product vision, a dinner party planner that lets the host create a menu, invite attendees, and let the attendees volunteer to bring items. Then, using inline Copilot suggestions, I'll expand into detailed requirements. I'm going to start with defining our users, the host, and the guests or attendees. Next, I'll define a feature section. Copilot is suggesting features like creating and managing dinner parties and adding menu items, inviting attendees, allowing attendees to volunteer to bring items. These align with our product vision, but it's also suggesting some features that are really kind of outside of our scope, like RSVP management and notifications. But for the moment, I'm going to think about those and move on to defining the web pages that we think we need. So the homepage should show the upcoming parties. We'll also need to have a page where we can create a new party. We need to have a party details page and a place where we can manage the attendees and the menu. Again, Copilot is suggesting some additional pages like RSVP and notifications that we don't think we need at the moment. So I'm going to stop here and remove those out-of-scope features and pages and get it back to just the features that we think we need for the application. And then I'm going to take a chance and ask Copilot through the chat window to improve the document that we have and fix some of the formatting issues that we have. And this is a really good example why we have to be very careful about what we're asking it to do, and then really review carefully what it actually did. It can be really helpful, but we don't always get the things that we wanted or get them exactly correct. It completely rewrote the user section into users and roles, but the definitions are fine, so I'll keep that. It also rewrote the features section with both in and out of scope requirements. It just keeps trying to sneak in those extra features that it wants that I didn't ask for. It really expanded the page requirements, adding some additional pages as well as role-sensitive views. For the moment, I'm okay with those changes. We may come back and revise that a bit later. It even created a data model section, and that we don't typically see in a requirements document. But assuming that that's information that comes from our subject matter expert or our customer, maybe it does make sense that it is in the requirements document. Since they're pretty close to what we're looking for, I think we're going to keep them. Finally, it created non-functional requirements. Again, I didn't plan to have that, but the items that it suggested are all good considerations for our application, so I'll leave it there. So for now, I'm going to accept these changes, but in a real project, I would probably scrutinize each section very carefully to make sure it aligns with our actual requirements. Instead of typing our prompts in ad hoc in the little bitty entry field at the bottom of the chat window, it makes more sense to create a prompts.md file to hold the prompts that we use in the project. This gives us a better reproducibility, and we can tweak these over time to make them better and reuse them on other projects. I'm going to start with creating a prompt that's going to create our solution. I want 3 projects in this solution: the ASP.NET MVC project, the Business Core project, which will be a library, and I want a XUnit unit test project. I'm going to also specify versions, because if I don't, it will probably use an older version, something earlier than the current. Both the web project and the test project will reference the business project. I also want to indicate that I don't want any authentication or authorization at this point. If I don't, it will put it in when it creates the projects. I also want to specify the library manager libman for our client-side libraries, and I want to use Bootstrap and jQuery and the jQuery validation libraries. Now we could copy and paste, but instead I'm just going to select the text for the prompt I want to execute, and then I'll type into the chat window prompt to tell it to just execute the code that I highlighted, that I selected. Now I've sped this up quite a bit, but this takes about 2 minutes to generate all of the projects. And it gave us pretty much the starter projects that you get when you create new projects in Visual Studio. Next, I'm going to work on the user interface. It's usually best to get the user interface done first because that informs the rest of the project. I'm going to ask Copilot to generate the home page, a detail page, a create dinner party page, and to make sure that they are properly connected to the layout page. I'm also going to specify that that's all I want. I don't want it to generate any controller actions except those to allow us to navigate between the views. So let's execute our prompt and see what we get. So we'll just tell it to execute the selected text, and we'll be polite about the whole thing. Now this is going to run for about 90 seconds. I've sped it up here so that we don't have to wait through the whole thing. And let's take a look at our controller action. It's created some dummy data for us. The controller actions look okay. Not surprised about any of this. Next up, I want to look at the layout to see if it incorporated everything there properly. And it looks like it did. I'm going to update the 2025 hard-coded to use a dynamic date using datetime.now.year. Take a quick look at the detail view as well as the index view, and they look okay. So let's run this thing. We'll build it, run it, and take a look at what we get. And the homepage looks pretty good. I am very pleased. I've always been happy with what Copilot generates for user interfaces. It does much better than I would be able to do. The detail page is not quite what I was looking for. It has guests and menus as separate pages instead of having it all in one place. So this kind of goes back to that invitation notification thing that it kept trying to do earlier. So I'm going to create a new prompt and ask it to fix that and put everything on one view. So we want to have guests, menu items, assignment of menu items to guests, and everything all on one on the same detail page. So let's give this a run and see what it does for us to fix the page the way we wanted it to be to begin with. Again, this prompt runs for about 90 seconds, and then we'll get our results. Now I'll do a quick build run and take a look at our resulting web page, see if it fixed it up for me like I wanted. So the homepage looks the same. Let's look at details. And it looks like we've got our guests on the left-hand side, the menu and the assignments. Hot dogs are unassigned. Let's see what happens. So all the guests are listed there. Okay, I like that. That'll work. Rule 3, build the user interface early. Now that we have our views and they're relatively stable, let's go ahead and move to the next step and define our view models. We'll use the views to inform how the view models are constructed. I'm going to let Copilot help me out here because it knows about our views and have it suggest the view models. I'm not thrilled with all of these view models, but they're okay. I'm also going to make sure to tell it to use the view models from our controller actions. I want to also, and as well as the views, I want to also tell it to add validation attributes and to enable client-side validation. Now that we've designed our prompt, let's highlight the text, go over and ask Copilot to execute the selected text. Now this took about 7 minutes. This was one of the longest Copilot executions that I've had in a while. There were several places where it had to ask permission to do some things, and that's typical. But eventually it did convert everything to use view models. And we can verify our controller to make sure that it's using the models instead of the previous anonymous objects. Now I'm going to go ahead and run this application and make sure that everything still works correctly. I don't expect to see anything new, but I just want to make sure that nothing is currently broken. So we build, it's a good sign. Here comes the home page, looks the same. We can go over to details, and I still have a great details page with all of our users. Perfect. All right, now that we have our user interfaces pretty well built, we can fill in the rest of the controller actions. So we know what those actions need to be. With some assistance, inline assistance from Copilot, I'll build out the definitions of the different controller action methods. I do want to make sure that it uses the view model and that it keeps the controller actions thin. In other words, they're not going to be functional just yet. So we'll get this set up and ready to go. And then I'm going to highlight all of this and issue a prompt to tell it to execute these actions. Now this takes about 2 minutes to build out the rest of the controller actions. And we review real quick just to make sure that it didn't do a bunch of stuff that I didn't want it to do. And it seems that it is using the view model classes. It's also doing validation. It added the anti-forgery tokens. So everything looks good there. Let's run it and make sure that everything still works. And it does appear that we do have the additional functionality, and the old functionality that we have still exists. Now, as I review the chat summary, I realized that it did not wire up, or it didn't create controller actions for the detail page. So we're going to ask it to go ahead and continue with the detail page. This takes about 4.5 minutes. For whatever reason, it took a lot longer to do the detail page than it did the home screen. So it did seem to implement all of the functions we were looking for. I didn't have to specify them out individually. It knows what it needs actions for. So let's build, run, make sure that everything still works, and it appears as though it does. Next, we're going to work on our service interface, and we're going to apply one of the solid design principles called the interface segregation principle. So I want to start with my prompt, and since we already know what our controller actions look like, they can inform the definition of this service interface. This principle says, let's create that interface based on the exact requirements or needs of the calling function. The caller defines the interface. So I don't even need to specify what those are. I'm going to ask Copilot to analyze the controller actions and define that interface specifically based on its requirements. And I'm going to have it create a dummy implementation and remove all of the dummy data from those controller actions. Let's go ahead and execute this. So we'll put our prompt in to execute the highlighted text. And this takes about 3 minutes to execute. It does create the interface, which is pretty good. I like the way that it defined what the function should be, or it set up dependency injection for us and injected that into our controller class through the constructor. And it also created a big summary for us to review. So one of the things I noticed right away is that it used the view model classes as part of the service, which means it has to move those to the service project, and that's an architectural violation. I'm going to go ahead and accept the changes that it made, and we'll correct some of these issues later. So one thing you might notice is that it did not use primary constructors, and I prefer to use primary constructors as well as record types for the view models. So we're going to add those to agents.md, and I'm going to ask it to go fix any of the dependency injection opportunities to use primary constructors and to switch over to record type definitions. So you can see here that it did, but it still kept the fields. So I'm just going to get rid of the logger field altogether. We're not referencing it yet. And we're going to change the name of this to the dinner party without the underscore, and then delete the field. That way it updates all of the references to it, and we'll be using the primary constructor parameters instead. I think this is a cleaner, more modern style of C#. All right, up next, we're going to generate a unit test to specify how the service implementation should be done. So we already have our interface, and in this section, we're going to create instructions on how a class would actually be implemented to produce the functionality of our dinner party service. We want to use SQLite for our data store, and so we want the class to be named SQLite Dinner Party Service. The DB context is injected into our class that we're specifying so that we can create a fake DB context, or at least an in-memory database, to make testing faster. We also want to make sure that the unit tests are isolated and do not depend on any external resources. We can use mocking frameworks as necessary. We're not going to need that here. I also want to make sure that I tell Copilot to not implement any actual logic in the dinner party service. If we don't tell it, if we don't constrain or put these guardrails on, it will go ahead and create the class even before it creates the test. So we want to focus completely on writing the unit tests that define or specify the expected behavior. Now, let's select our prompt and ask Copilot to carry that out. This prompt ran for about 5 minutes, and it made some changes that I didn't really care for. For one thing, it added a key attribute to our entity classes, And that wasn't really necessary because they're already in the default format. So we had to go back in and ask it to remove those. I'm not going to show that because it just took a lot more time. So at the end of it all, we do end up with some tests, and I'm going to go to the Test Explorer and run those. I verified that they all fail, which is what we expect in test-driven development. Rule 4, let tests define behavior. Hey, are you ready to get this rolling and have an actual application? So let's give Copilot the instructions for generating our service implementation. So we have the unit test, which creates the specification. We're going to tell it to create the class SQLite dinner party service, create the methods according to the interface and according to the unit test requirements. We will make sure that the methods adhere to those unit tests. We also want it to use asynchronous programming practices where that's appropriate, the async await keywords. So let's give this a try. All right, so we're going to ask Copilot to do this prompt and let it get started. It takes it about 2 or 3 minutes to complete this task, implementing our service. It also runs the unit test to make sure that everything is working. And after it gets all finished with that, we're going to ask it to integrate that back into the web application. Now, despite asking for asynchronous programming, it did not create the async await functions. So we're going to verify that the unit tests work. We'll have to come back and do the async later on. Since our unit tests are working, I'm going to have it now integrate into the web application and set up the configuration for our database. And it gets started on that. Again, takes probably 2 to 3 minutes for it to complete that task. Now that it's up and running, we can take a look at our application. We'll reset the database so we have some test data. It's going to insert some records for us. Let's look at the details of one of the existing parties. And let's assign hot dogs to somebody. And save that. And we can see that it has stuck. Well, let's go verify to make sure that the hot dogs really did get assigned. And now let's create a new dinner party. Create a test party, put it in the park, and save it. And we'll see the details of our party. We can create our menu, create our guests. We'll go back to the list and we can see that it has been saved. Rule 5. Review and verify everything, then repeat. Okay, we're all finished. And there are, I'm sure, many issues to resolve, but we knocked this thing out about a half a day in real time. Here's what's important. We have a working, testable, architecturally sound application. The foundations are solid. Any cleanup needed is refinement, not rework. AI doesn't replace engineering discipline. It amplifies it. When you combine AI's generation speed with your architectural knowledge, requirements clarity, and verification rigor, you multiply productivity without sacrificing quality. The teams winning with AI aren't the ones using it like magic. They're the ones applying the same SDLC principles they've always used, just moving through the phases faster. I hope you enjoyed this video. Leave me a comment about what you liked best and how you plan to use AI to assist you with your work. In the description below, you'll find the complete GitHub repository with all the code we built today, plus the requirements.md file and the agents.md templates that you can adapt for your own projects. If you want to see more content on AI-assisted development, enterprise architecture, or advanced .NET patterns, hit the subscribe button. I'm always publishing new videos, deep diving into practical engineering techniques. And if you found this valuable, share it with your team. The conversation about AI and software development is just beginning. Let's make sure we're having the right one. Thanks for watching, and I'll see you in the next video.